Graphing recap. In the very beginning of this whole year, pre-calculus, we started learning about how to graph lines and parabolas, two of the most critical graphs that we'll do in this course. And both of which involve using the y-intercept and the x-intercept. Every graph you do in this class, you will need to label the x-intercepts and the y-intercepts. So before we go too far, let's look right at a line. If I want you to graph a line, I want you to find the y-intercept, I want you to find the x-intercept. And just to come up with an equation of a line, let's say I gave you 2x plus 3y equals 12. So this is the equation. First of all, how do I know it's a line? How do you know it's a line? There's no squared. It's just plain x and y. We good with that? All right, so here's what we're going to do. X-intercept and y-intercept. Y-intercept says when x equals 0. So that means I'm going to plug a 0 in for x, and I'm going to solve for y. So this term basically goes away. 2 times 0 is 0, right? No big deal. 3y equals 12, so what's my y-intercept? 4, done. Next one says to find the x-intercept. And of course, the x-intercept is instead when y is 0. And so what that basically means is that y term goes away. And so what's my x-intercept? And as simple as we can make it, we would draw our graph. Y is 4, x is 6. Shablam. There we are. Good? What becomes more involved are our parabolas, and let's be honest, those are the ones that really cause most of our problems. I will tell you that in the days ahead, I'm going to be doing certain sessions after school where I will simply focus on just one kind of graph or one kind of system, so that if this is an area of trouble, you want to make sure you come for that night of practice. We got to become very proficient. I believe the parabola question alone is worth 30 points. I want you to know how to graph a parabola, and I want you to know how to graph a line. It's that important. So when we're graphing a parabola, similar to the line, you're going to find the y-intercept, you're going to find the x-intercept, but added to that, we're going to have to find the turning point. So let's give you an equation here. Y equals x squared plus 5x minus 6. First thing, y-intercept. Xavier, what's the y-intercept? That would be for the x-intercept, you would have to factor it. But for the y-intercept, all you would have to do is plug zeros in here. And what do you find it to be? Negative 6. This is always, that constant is your y-intercept. Do you all remember that now that I'm shouting it out? Hopefully we do. So our y-intercept is negative 6. We good? All right, x-intercept. This is the one, as you were talking about before, is where we're going to plug 0 in for y. And then it looks like a factoring question that you're familiar with. It becomes a little more obvious. All right, we've got the x and the x. What multiplies to give me 6? And at the same time is going to subtract to give you 5. We definitely need 1 and 6. Why not 2 and 3? Because it doesn't subtract to give me 5. So, all right, different sign, bigger one is positive. So there we have x equals 1 and x equals negative 6. So our parabola is taking shape here. We've got it crossing at 1. We've got it crossing at negative 6. Sorry, I'm a little messed up there. All right. And this crosses my y at negative 6. This is definitely looking a little messed up here. But it'll work. My turning point. Where is the turning point? How do you find the turning point? Halfway between your x-intercepts. If that's not so obvious to you, then what we want to do is we want to do negative b over 2a, which simply means negative b would be negative 5 over 2 times 1. So it's negative 5 halves. How would you find the y? Come on, how do you find the y? Go ahead, Zach. Plug it back into the equation. You plug it right into this lovely little thing. You'd have negative 5 halves squared plus 5 times negative 5 over 2 minus 6. I'm just going to let those of you watching at home can see our answer there. Negative 49 over 4 and see the work there. Now, exponentials and logs, they look complicated, but truthfully, they're the easiest graph that you're going to do. 2 to the x, 3 to the x, e to the x, 100 to the x, 50 to the x. It really doesn't matter. If it has an x in the exponent, then this simple graph all looks basically the same. They all start by the x-axis. They never touch it. And then they swoop right up. They climb incredibly fast. They start very slow, and then they climb incredibly fast. Regardless of the kind of graph it is, though, they will all look relatively the same, and they all will cross at the same number, which is 1. The reason for that is because this is when x is 0. And whether we're talking about 2 to the 0, 3 to the 0, e to the 0, or etc., anything to the 0 power is 1. The only difference, by the way, between 2 to the x, or 3 to the x, or 4 to the x, or 10 to the x, is basically how fast this thing would climb. If that was 2, if the brown depicted 2 to the x, and that would be 3 to the x, then the next one would be 4 to the x, and we would keep just, you see, understand it just climbs faster. That's the only difference. But to you, when you're only graphing one of them, it's just whoop, one little swoosh. That's it. Okay? Now, we've already learned in the last chapter that logs are the inverse of exponentials. And so what that basically looks like then, and I'm going to just draw it on the same graph, but I'll draw it below here. It basically looks just like this, but remember, it's a reflection in the line y equals x. So what it looks like instead is it runs along the y instead of the x, and then comes up. And it also crosses the axes at 1, but this time it's the x-axis. So again, it runs right along this y and then swoops, and it slowly climbs. It takes a long time, but it keeps climbing and climbing and climbing. And that is your log graph. Whether it's log base 2, log base 3, natural log, log base 10, doesn't matter. They all take on the same look. And those are 4 of the 5 basic graphs. The 5th kind is your trig graphs, which hopefully we're quite familiar with at this point. Okay, does everybody have the log graph written down? So let's do some practice questions. And the slide I skipped basically has to do with just 3 steps. You're going to solve the equations, and you're going to graph these equations. You got to solve for x, solve for y, graph them. And so some people choose the graph first. It really doesn't matter which order. Regardless, you're going to have to always have a graphical solution and an algebraic solution. Okay? So how does this work? 3 to the x and y equals 9. Let's try this out. The first graph, let's just do this. What does 3 to the x look like? What does that graph look like? Just draw it. What does it look like? That's that one that kind of starts by the x-axis and swoosh right up, okay? So everybody draw that 3 to the x. I'm not going to be that picky about it because if you remember for the CLEP exam, it's 2 minutes a question. I don't need you wasting your time labeling something. So do you have to label it? Nope. I should be able to tell the difference. But you do have to label them with your intercepts. Where does this cross? 1. So we're going to label that with a 1. Now, y equals 9. Should be an easy graph. Y equals 9. Where does that thing, how does that look, rather? It is. It's just a horizontal line that goes straight left to right. Very good. All right, so there's 9. We're going to label that intercept as well. Okay, now our job is to figure out this point of intersection. That's the whole idea of solving a system of equations. Where do these two things cross? And so that's our next part. This is the algebraic part, and yes, I do want you to show your work. I know you typically, I say, don't bother showing your work. This is where you got to see your work. So when this says y equals 9, and this is y equals 3 to the x, what I want you to recognize is that basically in place of y, we're going to plug in that 9. And so this is 3 to the x equals 9. And if it's as easy as something you can do in your head, I want you to set up that equation, and then I want you to just give me the answer. If you have to use inverses, then by all means, feel free to. But do we know 3 to what power is 9? It's just 2. And so that means that this x value is 2. Well, what's the y value? How do you know? Because it says y equals 9. Don't overthink that. Don't make it too difficult. You'll notice that the first few questions in your homework assignment tonight basically look very similar. Gives you an exponential. Slap that thing down there. Gives you another linear equation, and then it just wants you to solve it. That's as simple as I can make it. Let's try another one. Whoa, 3 to the x equals 2. So what are we going to do? 3 to the x. What's that graph look like? Swoosh. Crosses at 1. Please make sure you label it. X equals 2. What does that look like? Very good. Vertical line. But we got to figure out that point of intersection. So we have y equals 3, and in place of x, I'm going to put that 2. So I have y equals 3 squared, which is 9. And so this is the point something 9. What's the x value? Are you all following this so far? It's just a matter of plugging that stuff in. All right. Let's try this one. 3 to the x and y equals 5. Go ahead and try and graph that yourself. Thank you. You can tell, and when you look at the graph, that there actually is a value where they cross. Now, whether we can determine it or not, that's the other question, because when you actually are solving this and you say, okay, 3 to the x equals 5, you can't figure out, wait, where does that happen? Because I know 3 squared equals 9, and I know 3 to the 1 equals 3. So what's that number? And so this is, remember, where logs come in. So how do I solve this question? How do I get rid of that 3? Log it. Log base 3 of both sides. And so you log base 3 both sides. You get x equals log base 3 of 5. And as ugly as that seems, that is the x value that you would have there. And what's the y value? 5. And that's the answer that I'm looking for. Good with that? Now I'm going to skip this question here, and I guess I should do at least one log. Let's look at one log question here. We've got y equals log base 3 of x. Now, can you tell me, what does that graph look like? It's the opposite of swish, right? It's not the swish that goes up. It comes up, and then it flattens out a little bit, crosses again at the 1. And where does y equals 2 show up? How does that look? Good, Dylan. It is a straight line crossing here at 2. But we've got some point of intersection, so we've got to be able to find that. So similar to before, in place of y, we're going to put that 2. And we know that logs are exponents. Or by looking at our inverse chapter, how do you get rid of log base 3? You 3 it, right? We 3 it, and that goes away, and so I get x equals 3 squared, right? Not 3 times 2, but 3 squared, and so that means 9. So my x is 9. What's the y value? Easy enough. You'll really see how this chapter solidifies a lot of the things that we've done this year. Let's skip down to these last two questions. Cosine of x equals y, and then we have x equals pi over 4. So go ahead, graph your cosine curve. So you should have your cosine graph that looks something like that. And we have x equals pi over 4, a little bit trickier. One of the things to understand is that pi is a number, right? So when I say pi over 4, that's really just like saying x equals a number. It's a number you're not real comfortable with, but just the same, it is a number. So what do these x equals a number graphs look like? Straight up and down. And so if this is pi over 2, where is pi over 4? Is it to the left or to the right? It's to the left. And so that looks right there. And that would make this guy pi over 4. So we have a point. I know the x value already because it says x equals. And to find y, we'd go y equals the cosine, and in place of x, put pi over 4. What is the cosine of pi over 4? Square root of 2 over 2. And we have that cosine graph done. Not too bad. Not too bad. What we'll take the rest of the time for us today is to do this last one. Now, it is helpful to be able to recognize what kinds of graphs we're looking at. When you look at it and you know, oh, it's cosine graph, so it's going to be this wavy looking thing. Or you know it's an exponential, so you know it does that little swoosh. Or you know it's a log, so you kind of arcs funny. What are these graphs that you see in front of you with y equals x squared plus 4x? What's that? It's a parabola. How do you know, Sydney, it's a parabola? The x squared. And the other equation, y equals negative x plus 6, that is a line. Okay, good. So let's start by graphing these. If you've been doing these graphs all along, then you're pretty well versed in how to graph these parabolas. I'm going to kind of speed through this a little bit, so try to stay with me, but if you need to get help with parabolas, please do so. All right, so the first thing we've got is y equals x squared plus 4x. I know the y-intercept is 0 because there's no constant here being added. For the x-intercept, that's going to require me to factor. And what do you notice when you're factoring this? What can we take out of it? You take out the x, and we're left with x plus 4. And so, Rebecca, what are the two roots that we have here? X equals 0 and x equals perfect. So my parabola is already starting to take shape. It's crossing at 0, it's crossing at negative 4. Alicia, where is the turning point? Turning point. I couldn't hear you, so I don't know what you said. Two things, two options. One is it's halfway between your x's, or negative b over 2a. So to me, when we're talking about negative 4 and 0, can you figure out what's halfway between those two? Negative 2 seems a little bit simpler, doesn't it? Yes, negative b over 2a would have worked as well. You plug negative 2 in here, and just for timing's sake, I'm just going to do that for you. You end up getting negative 4. Okay? So there, I've got my parabola. Now let's just quickly do the line, and then we've got to solve this thing. See, we're still not even through the solving part. With the line, what's the y-intercept? 6. The x-intercept requires a little more work. That's where we're going to plug 0 in for y, and we're going to solve it. So, Eta, how are you going to solve that? Solve this right here, the x. 0 equals negative x plus 6. We got to get, okay, if you subtract the 6, then you have negative 6 equals negative x, and then you'd have to divide by that negative 1, right? So I'd get x on the right, and I'd get positive 6. So on my graph, and we're going to draw it on the same one, that means my y is 6 and my x is 6. Now, how many times do these graphs cross? It looks like once, but it actually crosses twice, because you know those fancy arrowheads that those lovely middle school teachers made you do? And they said, just put that arrow, because it means that that graph is continuing on. Just because your pencil lead stops doesn't mean the graph actually does. So keep that in mind, that this really is coming over here, and we should expect to not just get one point of intersection, but 2. So let's solve this. Believe it or not, all that work was just to graph them. The solving part is now where you basically are saying x squared plus 4x, and in place of y, we're going to put this whole thing in that spot. So I have y equals negative x plus 6, and I'm going to solve this. So Zach, what do you think is the first thing we want to do in solving that? Okay, before you can factor, what do you have to be able to do, though? You got to get this stuff together, right? So how do I move that stuff? How do I move that negative x? You're going to add it, and then you're going to subtract that 6. And so, does that make sense to everybody? So you have x squared, you have plus 5x minus 6. Now it's equal to 0. Now you can factor and figure out where these two things cross. Are you good with that? So Emma, why don't you factor that for me? How do I factor x squared plus 5x minus 6? X minus 1 and x plus 6. And so I find that it's x equals 1 and negative 6. So that makes this guy the 1 and this the negative 6. And we still got to find the y. Here's the thing. It doesn't matter which equation you use at this point to find y's. If I want to find the y values to each of these, it doesn't matter. I would choose the simplest equation there is. And this would be one in which I would use the line for because I find it much simpler. So when you plug that 1 inside, you get negative 1 plus 6 or 5, so that makes that 1, 5. And when you plug negative 6 in there, it becomes 12 because the two negatives cancel each other out. So there's your 2 points of intersection.